Welcome to my kcse revision channel. Teacher James Marita, Tribal Sports High School. Kindly subscribe my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision from one work, and our topic is water and hydrogen. And today we are looking at the summary of the diagrams that can be set from water and hydrogen. So we have our first diagram where we have burning a candle, then we have anhydrous copper 2 salvate, then we have anhydrous copper chloride pepper, we have lime water, and then you can see we have this is a white precipitate. So in this first experiment is whereby we are burning a candle. As we know that when a candle burns in air, it normally produces water and carbon dioxide. So we have the use of this funnel shape. Why do we use this funnel shape? So if you will be required to give the reason why the funnel shape is normally used, it is just to increase the surface area for the candles to burn in air. That is why we are using that funnel shape. When a candle burns in air, it produces two products, as I've said. It produces carbon dioxide and then it produces water. So this anhydrous copper 2 salvate and anhydrous copper chloride pepper, they are used here in this experiment to confirm that the liquid produces this water. In that case, what happens here? The anhydrous copper 2 salvate, anhydrous copper 2 salvate turns from white to blue. If the anhydrous copper 2 salvate turns from white to blue, that one will indicate that the liquid produced is water. If we have a copper chloride pepper, a copper chloride pepper changes from blue to pink. That one will also indicate that the liquid produced is water. So this observation, sometimes you will be required to explain the chemical test for water. So you are required to explain the chemical test for water. You just say the anhydrous copper 2 salvate, it turns from white to blue, and then we have a blue copper chloride pepper normally changes to pink. Now we have lime water. The lime water here is just calcium hydroxide. So this lime water here, this is the calcium hydroxide. So the calcium hydroxide here, it is normally used to test the presence of the carbon dioxide. Remember, we have said that there are two products produced from here, that is CO2 and water. So the CO2, to confirm that the gas produced is CO2, the CO2 normally reacts with calcium hydroxide and then it forms a white precipitate. So that is what you can see in this YouTube, where we have white precipitate is observed in lime water. That is when the carbon dioxide passes through the calcium hydroxide solution. We have the second experiment. The second diagram represents the preparation of hydrogen gas. In the laboratory preparation of hydrogen gas, we have a reagent of a diluted hydrochloric acid, and then we have the zinc granules. So in that case now, we react a diluted hydrochloric acid with the zinc granules, then you receive the purpose of the hydrogen gas. So if you can have now here the zinc metal or the zinc granules, we react with the dilute hydrochloric acid, then we have the zinc chloride, and then we have this hydrogen gas. The hydrogen gas, if we require the dry, it is passed through a concentrated sulfuric acid or anhydrous calcium chloride. It can be dried, and then the methods of collecting the dry gas in this, we have another diagram here, whereby we are collecting the dry hydrogen gas. So the dry hydrogen gas is normally collected by the upward delivery method, or what we call it the downward displacement of air. So in the first case, we have hydrogen here is collected over water. The reason why this hydrogen is collected over water is because hydrogen is insoluble in water. So it is insoluble in water. That is why we normally collected over water there. And I've said that if the hydrogen gas is required dry, the dry hydrogen gas normally collected by the upward delivery method or the downward displacement of air. So the purpose of this concentrated sulfuric acid or the anhydrous calcium chloride, these two, you either use a concentrated uh, sulfuric acid or you use anhydrous calcium chloride to dry the gas. So dry hydrogen gas is normally collected by derivative, the upward derivative method. So we have another diagram here whereby the oxygen, the hydrogen gas produced may burn in air. So we have at this diagram, it is the same, but in this case here now, the hydrogen gas produced is normally burned at the church. So there are some questions that you are expected to answer from this part. Maybe you write the two questions that will take place here. There are two questions which can take place from this particular diagram, as you can see. One, we have the burning of this hydrogen at this church. So the first one, we have the diluted hydrochloric acid combining with the zinc granules. Then you will have the effervescence of the bubbles of hydrogen gas. So we have zinc granules combining with the diluted hydrochloric acid. Then you have the zinc chloride, and then of course you have hydrogen gas, what we have said in the first diagram. Then the second equation reaction here is when now the burning of this hydrogen in air. The reason why we are burning this hydrogen, if hydrogen is allowed in the air, the reaction between hydrogen and oxygen is very explosive. And that's why now the hydrogen is burned at the church. So at the church now you will have the hydrogen gas combining with oxygen, and then you will have it will just form water. So understand this experiment where here we are having a collecting hydrogen over water. Here we have collecting a dry hydrogen by the upward derivative, and in this one here we have now burning of that hydrogen in the air, because a reaction between hydrogen and oxygen normally is very explosive. We have now the other diagram where we have a reaction with lead oxide. That is now you talk of the properties of hydrogen. Hydrogen gas normally is a reducing agent. It can reduce the metal oxides to their respective metal. So in the first experiment, you can have a reaction with lead metal. So what happens here? You have a dry hydrogen gas, then we have heat, then we have this lead metal, and then we have hydrogen burning at the jet. So in that case now, the lead oxide will change color from yellow to orange and finally to gray. That is the observation that you will get from this experiment. So a water vapor condenses on the cooler parts of the apparatus. And those are the observations you can make from that one. It is because here the hydrogen gas is acting as a reducing agent, whereby it will reduce the lead oxide, for example here, the lead oxide to lead metal, which is gray, and then we have a water vapor which condenses on the cooler parts of the apparatus, and then we have the water there. The second one, we have copper oxide, the same reaction as that, whereby the dry hydrogen will react with the copper oxide. The copper oxide now will be reduced to copper metal, and then we have a formation of water, which will, in this case, a water vapor which will condense on the cooler parts of the apparatus. So what observation will you make here when you are using copper? In the copper, in this case, copper oxide is black. So if it reacts to the hydrogen gas, it will change the color from a black solid to a brown solid, and of course there is a formation of a colorless liquid. So we have a black copper oxide turns to brown. So if you require the question of the reaction, we just have a copper oxide metal here. In this case, this one here is black. This is a black solid here. So we have this is a black solid. It will combine with hydrogen, a dry hydrogen, and then we have a brown solid of copper metal. So this one here is brown, this brown solid, and then we have a water vapor which condenses on the cooler parts of the apparatus. Then we have a colorless liquid there. We have here a dry hydrogen gas, then we have a copper oxide in a porcelain pot, and then we have anhydrous copper sulfate. Already we have carried out this experiment, we have already talked about this one. The purpose of this anhydrous copper sulfate, it is to confirm that the liquid produced is water. We have the colorless liquid produced here. Of course, we have that this is water produced here. So this is the water produced there. So to carry out an experiment, a chemical test, to show that the water produced there is a liquid, you normally use an anhydrous copper 2 salivate or a copper chloride paper, as we have said in our first diagram. Then we have the proportion. What you can say from this experiment here, from this one here, is that the white anhydrous copper 2 salivate turns blue, as we have said, to indicate that or to confirm that the liquid produced is normal water. The precaution which is normally taken during this experiment that the air is driven out of the apparatus to ensure that the hydrogen panning at the jet is pure. In that case, to avoid explosion with air, because the reaction between hydrogen gas and oxygen gas is very explosive. Therefore, here in this experiment, the air must be first of all driven out of the apparatus to ensure that the hydrogen burning at the jet is pure. Then we have another experiment similar. We have a dry hydrogen gas, where now you talk of lead oxide, as we have mentioned in our first case. So if you will be required now here to state the observation made in the hard glass tube. The hard glass tube, what you can say that a yellow lead oxide turns to orange on heating. This one turns to orange on heating, and then the solid turns gray. It turns gray because the lead oxide metal will be reduced to lead metal by that hydrogen. We have this experiment again, whereby now we are talking about a reaction between a metal and a reaction between a metal and a steam. So here we talk of metals like magnesium metal, like zinc metal, the iron metal. They do not react with cold water. And normally they react with the steam to produce the hydrogen gas. So from this diagram here, what you can see first of all, we have a wet sand. If you cannot use a wet sand here, you can use a soft cotton wool. So in a soft cotton wool or a wet sand, and then you will have a coiled magnesium ribbon. Now, some of the questions that you are expecting from this diagram is explain why the sand is heated first before heating the magnesium ribbon, or explain why do we heat the cotton wool first before heating the magnesium ribbon. The reason why we heat sand first, or the magnesium, we heat the sand first or the cotton wool, is just to generate steam that will react with the magnesium ribbon, and also to drive out the air that was initially on the flask, which might have reacted with the magnesium ribbon. Therefore, the magnesium ribbon should not be heated first. If magnesium ribbon is heated first, it will react with the air in the tube, forming magnesium oxide, which does not react in this case with the steam. Therefore, the sand or the cotton wool must be heated first. So in place of this magnesium ribbon, you can use zinc metal, or you can also use the aluminium. You can use the aluminium metal. Metals below lead in the reactivity series, they do not react with the steam or water. Therefore, they cannot be used to react here. And therefore, when you look over metals like sodium metal and potassium, they are not supposed to react here because the reaction here might be very explosive. So understand that from here, the magnesium ribbon should be heated, the wet sand or the cotton wool should be heated first to generate steam and also to drive out the air that was initially on the flask. Then the reason why the magnesium ribbon is coiled, it is just to increase the surface area for it to come in contact with the steam. That is the reason why we have this magnesium ribbon being coiled. And then we have the hydrogen gas is normally collected there, it's normally collected over water, as we have said. Then we have the magnesium ribbon combining with the steam. In that case, we will have the magnesium oxide. This magnesium oxide here now is, we have this is magnesium oxide as a white solid. We have that magnesium oxide as a white solid, and of course we have the hydrogen gas there. So how do you confirm that the gas produced is hydrogen? So if you are required to describe an experiment, a laboratory experiment, to confirm that the gas produced is hydrogen gas. So what you normally do here, you just use a panning splint, and then you lower a panning splint into a gas chamber suspected to be hydrogen. The observation you will make is that the hydrogen extinguishes a burning splint with a pop sound. That is simply how you can confirm that the gas produced is hydrogen. We have the last diagram where we have a reaction between a calcium metal and in this case water. Calcium metal can also react with water here and then it will normally generate steam. But at the end of the experiment, you realize that the solution in the beaker is a weak the solution in the beaker is a weak base. Why? This is because the calcium reacts with water to form a calcium hydroxide, which in this case dissociates partially in water. The solution formed, that is the calcium hydroxide, if you require to give the usage of this solution formed here, which is calcium hydroxide. Calcium hydroxide is normally used in the lab for the confirmatory test for the carbon dioxide gas, whereby it reacts with the carbon dioxide gas and then it forms a white precipitate. That is a very simple summary of the diagrams that can be set from water and hydrogen. Don't forget to subscribe, watch, and share. Thank you for watching.